So the thing is that sorting is an algorithm that arrange the element of a list in a certain order, right? So this is nothing but a sorting. So sorting is an algorithm that arranges the elements the elements of a list in a certain order, right? Certain order. Either it may be ascending or descending. Either it may be ascending or descending. And the output of the output is a permutation or reordering of the input. So the first thing that you should know that what are the application of sorting. If we talk about the applications, it used everywhere. Like that, when you are playing any game, like a when a player is moving in a FIFA, or in case of PUBG, when you are reloading a gun, or you are moving some steps forwards and then backwards, that is nothing but the sorting. That means, and every time when you reload a gun, or you are moving in a forward directions, or you are moving in a backward directions, whatever be the thing is that you are actually apply sorting every time. So that means that is important. That means in any applications, what you are using this sorting technique. Now the questions come. That means depending on the application, you should decide that which sorting algorithm performs better. So that's why there are lots of sorting algorithm out there. And the reason behind that is that depending on the application, some sorting algorithm will perform better than the other. So the thing is that when we are comparing, the classification of a sorting algorithm, there are different things. That means if we say there are two type of sorting, one is called comparison based sorting. One is called comparison based sorting. What is comparison based sorting? That means we are compare element by element, right? And in that particular case, comparison means elements of array are compared. Elements of array are compared with each other, with each other to find the sorted array. This is a comparison list, and there are several sort like that. Bubble sort is one of the example. Insertion sort, insertion sort. These are comparison based sort, and in that particular case, the and worst case, average and worst case, the time complexity, that is order of n square in case of bubble sort or insertion sort. And best case, that means in this two sort, best case, it is happening when that should be order of n when the array is already sorted. When the array is, we will see that already sorted. That means when the array is already been sorted or nearly sorted, so it will be better to use a bubble sort or insertion sort. And there is also comparison based sort, that is called selection sort. This is called selection sort. So the best, average and worst case time complexity is n square. The best, average and worst case. If we say best, average and worst case, the time complexity, you know the time complexity, that is n square. And of course it is independent. It is independent. It is independent of distribution of data. Independent of distribution of data. That is a selection chart. March sort. There is also, this is also, one of the example of, comparison based sort. And in that particular case, if you analyze the algorithm, the best case, average case, and worst case, the complexity, that is, order of n log n. And that is one of the tasks to remember the complexity, because that will be asked in different thing. That means it is application based. The thing is that there is also another algorithm that is called heap sort, right? Heap sort, in that particular case also you can say best case, average case, and worst case, that is in log n. And that is also this merge sort and the heap sort, that both are independent of distribution of data. So in that case you can say the best, average, and worst case, that is in log n. So, and another thing that is called quick sort. This is called quick sort. That means in sorting chapter we have to implement this type of sort, and it is important. And in that particular case, the uh, worst case, if you say, is worst case. This worst case will happen when you can say the array is sorted, or the or reverse sorted. Then when the array is sorted, when the you know array is sorted, or reversely sorted, and you can take the pivot element, and pivot element is taken in middle. In that particular case, that quick shot, that will give you the complexity, that is order of n square. That is the worst case, right? This is the worst case. And in case of best case and average case, in case of best and average case, the complexity is order of n log n. Complexity is order of n log n. So these are the comparison based sort. What are the comparison based sort? Then you can say that bubble sort, insertion sort, selection sort, merge sort, heap sort, quick sort. That are the different sorting techniques, and that are comparison based sort, because you are comparing element by element. Now there is a thing, that means this is called non-comparison. That means what we will see. We already that in case of comparison based sort, actually the algorithm will take order of n log n. That means less than order of n log n time you cannot sort anything, right? In case of comparison based sort. So you can say the lower bound of this comparison based sort is order of n log n. Now if we consider non-comparison, if we consider non-comparison based sorting, non-comparison based sorting, that means we are not comparing element by element. In that particular case, element of array are not compared with each other to find the sorted array. So in that particular case, what we can say, that elements of array, that are not compared. This is are not compared you know with each other, are not compared with each other to find the sorted array. And in non-comparison based sort, there are basically three sort. One is called radix sort, one is called radix sort. The thing is that in that particular case, the best, average, and worst time complexity is NQ. The best, if you say average, and the worst. This particular, the time complexity, that is linear, right? That is linear. That means order of NK. Order of NK, where k is the maximum number of digits, maximum number of digits in elements of array. But the thing is that, so you may asks the questions that in case of comparison based sort, what I'm saying that the lower bound, that means you cannot do the sorting with the less than the complexity of order of n-log, right? But the thing is case in case of non-comparison based sort, this is that is a linear, right? You can do the radix sort in linear complexity. So the question is that so why we should not use radix sort in a normal or general case, right? Because it has been proved that the lower bound in case of comparison sort, that is order of n log n, and that the questions comes that in case of log n radix sort or count sort or bucket sort, we take some assumptions, right? And the thing is that in case of radix sort, if the distribution is not even, that means there is a number say 0 1 2 3 up to 10 and then 1 crore 2 crore 3 crore 5 crore, then your the complexity is increased such that you cannot compute it with the less than order of n log n. So in that particular conditions, this non-comparison based sort will not work. So that's why we cannot use it in general cases. But of course, radix sort has its implementations. That means in some cases where depending on the applications, if we apply radix sort or bucket sort or count sort, that will give you the good performance. So thing is that the radix sort, and this is another thing is that is called count sort, and in that count sort the best average and worst case, the best average and worst time complexity, if you say about the time complexity, that is order of n plus k. And in the thing is when k is the size of counter, right? K is the size of this count array. So this is the count sort. And another thing that is called bucket sort. Another thing that is called bucket sort. So in that case, the best average time complexity is also order of n plus k. This best and average time complexity. Time complexity is order of n plus k, where k is the number of bucket. Number of bucket. Now, of course, there is a worst case time complexity will occur. If we can say the worst case, that would be order of n square. We can say if all elements belong to the same bucket, belong to the same bucket. So the thing is that I am just giving you the approximate time complexity. That means in an intuitive way thinking what should be the time complexity of that, but you should know that are the different types of the sorting that you should cover. That means this type of sorting you should implement by using your Python algorithm or any other language that will be better to implement. In C also you can implement this. But that is the difference between the comparison based and non-comparison based sort. You can also divide the algorithm, you can also divide the sorting technique in respect of in place, in place and out place technique. In place and out place technique. So what do you mean by in place? That means the thing is that is if it is in place, if it does not use any extra memory, if it does not use any extra memory, any extra memory to sort the array, does not use any extra memory to sort the array. And the thing is that among the comparison based technique, only merge sort, all other sort are in place, right? Means what is the in place sort like that? You can say bubble sort, bubble sort, insertion sort. In that particular case, you need not use extra memory. Insertion sort, selection sort, selection sort, you know heap sort, heap sort, that all are that is in place sort. And if we consider about the outplace, so this outplace sort, that means that you need extra memory for sorting. And of course when you are doing merge sort, you will see that we need an extra memory to perform this particular sorting technique. That means arrays that need to perform the merge, you will see the technique when we will discuss the technique. You will see that is the outplace sort. And the thing is that quick sort is also outplaced since it is recursive and stacked. If we are using recursive quick sort, right, that is also it can be taken as the outplace sort if we use the recursive version, because recursions, when we call the same function several times, that means a stack memory is used, right? Activations record, that will be stored in the stack. And the thing is that uh, that will it need extra memory, so that's why we are saying that that is the outplace sort. But the thing is that if we can modifying it to be a non-recursive is feasible, but that is non-trivial. Trivially, the quick sort that is implemented by using recursive version. So since this is a trivial version, so you are saying that that is one of the outplace sort. Now the thing is that count sort, or bucket sort, or radix sort, that all need extra memory. So that all need extra memory, right? So the simple thing is you can divide the sorting algorithm in two parts, in place or out place. That means if a sorting algorithm need any extra memory, right, then it is called outplace sort. If the sorting algorithm does not need any extra memory, then you can say it as a in-place sort. Now there is also the same sorting algorithm can divide into two parts. That is one of the important thing, that is called stable and unstable. This is a stable and unstable technique. And the thing is that means a same sorting algorithm has comparison based and non-comparison based sort. Same sorting algorithm has in place and out place versions, and the same sorting algorithm has stable and unstable versions. So what do you mean by stable? Stable means if it does not change, if it does not you know change the order of element with same value, with same value. So the sorting algorithm is said to be stable if two objects with equal keys appear in the same order in the sorted output as they appear input array to be sorted. So we know what is the meaning of that. Say, the number of elements are say 10, say this is 20, this is 20, say this is 30, and this is 10, right? That is the same element. Say we can represent it A with A, this is B, and this is B. But that is actually not represented, but this is, I'm just representing it like that. Now it may be possible that when you are applying sorting, when you are applying sorting technique, what will happen when you are applying sorting, the position will change. That means this is a and this 20 will be that 10 will be coming, and the thing is that this 20 position will changes, right, after sorting. So that is 20. That means output will you give the same thing. That means 10, 10, 20, 20, 30. That is not the thing. But the thing is that the position will be changed. That means before sorting, this 20 will be placed at there, and this 20 will be placed at there. Then it is not stable sort. This is unstable sort. Because when you are applying the sorting in case of some database applications, it may be possible that will give you unpredictable results. The same name, the same name, there should be some same name, and you have to take only 10 students, right? And depending if you search with respect to the name, it may be found that the name that would not be getting chance, he will get chance like that. He will be getting chance like that. মানে ধরো তোমার একটা ডেটাবেসে 10 জন আসে, 10 জনের নিয়ার অ্যাবাউট ধরো লাস্ট 6 জনের বা মার্কস সেম, বাট তোমার তার মধ্যে 5 জনকেই তুমি অ্যাডমিশনস নিতে পারবে, then what will happen? তুমি যদি এরকম শর্ট করো তাহলে তলারটা যদি উপরে চলে আসে তাহলে হয়তো যে আসল চান্স পাওয়ার সে না পেয়ে পেছনের লোকজন চান্স পেয়ে যেতে পারে। That's why that will create a problem. That is one of the example, but that may be, there are lots of example you can see where that instability will create a problem. So the thing is that, so what are the different, we know the sorting, there are different types of sorting algorithm. So the thing is that the particular selection sort, that particular selection sort, that selection sort, that is not stable, like that. So first we will start with bubble sort. In case of, the bubble sort, that is stable. Bubble sort is stable. That means, the element that will not change order only when a smaller record follows a larger, right? Insertion sort. Insertion, sort, that is also, that is a stable sort. This is a stable sort. And but the problem begins with the selection sort, right? Problem begins with the selection sort, because the selection sort, the normal selection sort or straight selection sort, that is unstable in nature, right? That is unstable in nature. So that means you can, there is a paper where you can, if you can follow, then you will see that they will they did it, the selection sort, that the unstable, the set selection sort, they will modify the selection sort, and the modified versions of the selection sort is a stable versions. But the thing is that the normal selection sort that we studied, that is unstable in nature. Merge sort, that merge sort, this merge sort is, that is also stable. The heap sort, this heap sort is, this is unstable. So depending on the applications, you cannot apply the unstable sort, where the result may vary. And there is a quick shot. This is, this is also unstable. The count sort, the stability depends on the, underlying algorithm that we are using. That means this stability, we will see that stability that depends on the under, lying algorithm that we used. And bucket shot, that is, stable. Radix sort, that is also the stability depend on the, in case of radix sort, the stability that depends on the underlying algorithm that we are used. So that is the different versions, right? That are the different versions. So now the thing is that if we start with the bubble sort, right? If we start with, bubble sort, so that one is the basic versions of the sort. So that is the simplest sorting algorithm, and it works, by iterating the input array from first element to last, and comparing, each pair of element and swapping if it needed. So bubble sort continues its operations until no more swaps are needed, and the algorithm gets its name from the way the smaller element like bubble to the top of the list, right? যেমন ভাবে বাবলটা ঠিক আস্তে আস্তে ছোট থেকে বড় হতে যায়, তেমনি বাবল সর্টের এক একটা পাশে যে বিগের এলিমেন্ট যেটা হবে সেটা লাস্টে গিয়ে বসে যায়, right? That if we see an on example, then it would be clear like that. Say first pass, that means the elements say that are 5 1 4 2 8. তাহলে বাবল সর্ট কি করে, the bubble sort কি করে, ফার্স্ট ও কম্পেয়ার করে, কার সাথে কম্পেয়ার করে, এর সাথে এর কম্পেয়ার করবে, ফার্স্ট এলিমেন্ট অ্যান্ড সেকেন্ড এলিমেন্ট, and first element and second element যদি compare করে, and if it will find that this 5 is greater than 1, then what will happen, this 1 and 5 will be swapped, right? So in the next, it will be first pass, it is going on like that. That means again it will compare these two elements, right? If this 5 is bigger than that, that means these two elements will be swapped. Again this, it will be compared the next two element, then again 5 is bigger, so 1 5, that will be swapped right there. And in the plus 1 4 2 5 8, that is the last two element. So the last two element you need not to swap, right? So you know after the first pass the biggest element should be placed at the right positions. So that's why after first pass, তো তার মানে কি এক একটা পাসের পর কি হচ্ছে সবচেয়ে যে বিগেস্ট এলিমেন্ট সেটা কোথায় চলে যাচ্ছে, লাস্টে চলে যাচ্ছে, রাইট? তার মানে এটা হচ্ছে ফার্স্ট পাস। সেকেন্ড পাসে কি হবে, সেকেন্ড পাসে দ্যাট উইল স্টার্টেড, মানে সেকেন্ড পাসটা কি হবে, আমার আটটাকে তো আর চেক করার দরকার নেই, রাইট? মানে একটা এলিমেন্ট কম আমি চেক করব। So in case of second pass, the element that we will get the order of element, that means again it will be start from first one. So it is right there. So the thing is that this is 14258. So this is 14258, and 1 and 4 that will not show up, so that will remaining thing. So the thing is that this is also 42, so that means the 4 will be 2458, right? That, and again this is that should be 4 and 5, right? So 4 and 5 will not swap, so it will remain like that. And 1 2 4 5 8, that it will also not swap. So you need not to check, right? That this last step you need not to check, because that will be less than one step that you need to solve, because already 5 would be in the similar place. So that in the second pass the second largest element should be placed in the right positions, right? So the thing is that in that particular case the bubble sort will uh, that will be going on like that. That is the thing that will be going on like that. So just a, so the thing is that is the concept of the bubble sort, right? So in case of bubble sort, if we write a simple functions, right, that in C what the bubble sort will do, right? This is the bubble sort. If you write it like that, we are passing the array and we are passing the number of elements. So the thing is that in that particular case, how can we write, say I j, and that is temp, and say for I is equals to 0, say I less than n, I plus plus. The thing is that in case of this for, it will be started from j is equals to 0, j less than n minus I minus 1, j plus plus, right? Why I am writing like that? Because at every pass the biggest element will be placed at the last position, at correct position. That means in the next pass you need not to compare, or you need not to compare all the elements. That means in every pass, since one element will be placed in the right position, so in the next pass you can compare less than 1. So that's why I am writing n minus I minus 1. Now what will happen if if the element at j positions that be greater than the element at j plus 1 positions, if it happens, then we have to swap, and swapping can be done in different way. That means by temporary variable, you can place the array element in temp, and then array j should be placed in array j plus 1, and the thing is that an array j plus 1 that is equals to 10. So that is the the simple process by which you can and I can use the printf statement. That means that is the sorted array that I want to print. So that is nothing but say for I equals to 0, I less than n, I plus plus, and I am just printing the thing. I am printing the corresponding element. So this is the simple bubble sort. That means you should implement in Python if you can, and I know if you know the technique it will be easier to implement, and to compute it, it will take the complexity that we will say order of n square, right? If we consider worst case, worst case it will order of n square. Now that will you have to try that whether you can implement the optimized bubble sort, and why we need the concept of optimized bubble sort. The concept is needed because in case of this bubble sort, what we know, if the user will give, say, the user will give the sorted input, right, like 1 2 3 4 5 6. So what will happen, it will compare this in the first pass, and after first pass you are comparing each and every element and no swapping will occur, right? But you are still doing the same thing. That means when I equals to 1 you are doing, you are comparing this. When I equals to 1 you are again comparing the same element, and every time when you are comparing, no element has been swapped. So the thing is that, so can we optimize the thing? That means if the, you know if the user will give sorted input, and if no swapping will occur, right, if the no swapping will occur, then your bubble sort will automatically terminate, right, it whether it be possible or right. That is the optimized version. তার মানে আমার যদি ইনপুটটা শর্টেডই হয়, তাহলে তো আমার একবার পুরো ফার্স্ট পাসটা চলার পর আমি কি বুঝলাম, এটা হচ্ছে ফার্স্ট পাস। এই ফার্স্ট পাসটা চলার পর আমি বুঝলাম কোনো সোয়াপিং হলো না। তাহলে কোনো যদি সোয়াপিং না হয়, তার মানে এটা আমি বুঝে গেলাম এলিমেন্টসগুলো শর্টেড, রাইট। কোনো সোয়াপিং যদি না হয়, তার মানে আমাকে আর সেকেন্ড পাস, থার্ড পাস, ফোর্থ পাস চালানো তো আননেসেসারি। বাট আমার এই যে বাবল সর্ট অ্যালগরিদম আমি যেটা লিখেছি, সেটাতে কিন্তু তা হবে না। মানে ফার্স্ট পাসের পর যদি কম্পারিজন করে দেখে কোনোটা সোয়াপিং হচ্ছে না, তাহলে কিন্তু অটোমেটিক্যালি সেকেন্ড পাসে যাবে, দেন থার্ড পাসে যাবে, দেন ফোর্থ পাসে যাবে, রাইট। দ্যাট, বাট দ্য থিং ইজ দ্যাট that will not desirable, right? Because bubble sorted বিউটিটা কোথায়, যদি এলিমেন্টসগুলো অলরেডি সর্টেড হয়, তাহলে বাবল সর্ট আর যদি দেখে যে কোনো কম্পারিজন হচ্ছে না, তাহলে ওর আর কম্পিউট করার দরকার নেই, রাইট। মানে ওর কম্পিউট করে আর কি হবে, ওর ওইখান থেকে লুপ থেকে বের হয়ে গেলেই that would be easier for this. So in that particular case, what will happen, the optimized version আমি একটা ফ্ল্যাগ বলে একটা ভেরিয়েবল রেখে দিলাম, ইউ ক্যান টেক এনি ভেরিয়েবল, রাইট। অ্যান্ড যদি তুমি দেখো যে যে ফ্ল্যাগ ভেরিয়েবল মানে কোনো এক্সচেঞ্জেস হচ্ছে না, রাইট, মানে আফটার কমপ্লিশন অফ ফার্স্ট পাস, ইফ there is no exchanges, right, then you can understand that the element you know is already been sorted. So what will happen, that means you know you can write that within the for loop, say I equals to 0, say I less than n minus 1 or I plus plus, whatever be the thing, and I am writing flag or x changes or something. A variable is taken that may be taken as a 0, and then we are doing another for loop. We are applying another for loop, that is j equals to 0, j less than n minus I minus I, j plus plus. This is j plus plus. And what we can say about that, uh, if it is not, that means if the you know if we do the comparison, that means if this is array j is greater than array j plus 1 and dot dot dot, and then you are just writing a variable exchanges plus plus. That means when the comparison will occur, the exchanges will plus plus. If this not, right, that if this, it will not happening, right, that we are putting exchanges is equals to 0, and for j equals to, right, that you are doing exchanges plus plus. And the thing is that after completion of that, that means if we did that particular thing, that means if there is a swapping, right, that there is a swapping function, you can write it like that. If the swapping will happen, then the exchanges will increment it, right. But if the swapping will not happen, then the exchanges will not increment it. So every time when I equals to 0, this will perform, and after the performing, if I am checking like that, if exchanges equals to 0. That means after first pass, no exchanges will occur. Then what will happen? I can break from the loop, right? I can break from the loop, and I can, you are not continuing the loop, and that's all. That means you are just using a variable which you make 0, and if there is no comparison will occur, right? No comparison will occur. You can make it, if the comparison occur, that means you are implementing the exchanges variables value. If not, then exchanges is 0. So the thing is, if exchanges is 0, then you just break the loop, and the thing is that you are printing that elements are already been sorted. So that will happen, and that will be, that will be the thing আমরা যেটা করি actually. So that is the, that is nothing but, the implementation of the, you can say, the bubble sort and modified bubble sort. So there is another sort that we should cover, that is the insertion sort. Your task is to implement at least this type of sorting, like in bubble sort, modified bubble sort, and we will cover, insertion sort. At least you should, try to implement this in Python. So insertion sort, when we should, the main thing is not like you have to implement it. The main thing is that depending on the applications, which sort you should use, that is the main thing or main concern, right? So the thing is, insertion sort, is the, algorithm. Insertion sort is the algorithm of, choice. Either, when the data is nearly sorted, sorted. That means this is the algorithm of choice, either when the data is nearly sorted. Why? Because it is adaptive. Because it is adaptive. It is adaptive. Or when the problem size is small. When the problem size is small, because it is low, it has low overhead, because it has low overhead. And the thing is that an insertion sort also is an efficient algorithm for sorting a small number of elements. And insertion sort works the way many people sort a hand of playing cards. তুমি ভেবে দেখো প্লেইং কার্ড কিভাবে করে। ধরো যখন কেউ তাস খেলে, তখন আমরা কি দেখি যে প্রথমে পাইল অফ কার্ড, ধরো আমি বলতে চাইছি যে তোমার কিছু কার্ড যারা ডিস্ট্রিবিউট করে টেবিলের উপর পড়ে আছে, আমি ফার্স্ট কার্ডটাকে তুললাম, তুলে কোথায় রাখলাম? হাতে রাখলাম, রাইট? সেকেন্ড কার্ডটা যদি দেখি সেটা সেম কালারের হয়, মানে যদি হার্টস, ধরো হার্টস আছে, হার্টসেরই হয়, তাহলে আমি যদি 2 পেয়ে থাকি আগে, তাহলে 3টাকে কি করব? আমি রাইট প্লেসে বসিয়ে দেব। তারপরে যখন আমি ধরো 4 পেলাম, সেটা অন্য একটা কালারের, আমি তাকে কি করলাম? 2 3কে পাশাপাশি রাখলাম হাতে, তার পাশে 4টাকে রাখলাম। তার মানে তুমি যখনই হাতে তোমার যখন কার্ডগুলোকে রাখছো, তুমি কিন্তু সর্টেড ওয়েতেই সবসময় রাখছো। That is not the final sorted thing, but the thing is, when you pick up a card from the table and you want to place it in your hand, you are doing in a sorted format. তাই আমরা করি। তার মানে we are started with an empty left hand, and the cards face down on the table, and we then remove one card at a time from the table and insert it into the correct positions in the left hand. And the thing is that to find the correct position for a card, what will happen? We compare it with each of the cards already in the hand from right to left. That we did in case of insertion sort. And insertion sort, because what I am learning here, this is Python data structure, right? that means the data structure. If you want to know the data structure, that means if you have to know the algorithm first. That means this is the algorithm for insertion sort. This is the algorithm for insertion sort. The insertion sort algorithm is like that. Say there should be some input. Input is nothing but a sequence of n number, a sequence of n numbers. That is nothing but the input. And what is output? The output is a permutations, right? A permutations. A permutation, that means after reordering, right, the input sequence. That means reordering. A permutation of the input sequence. Permutation of the input sequence, that means if the number is a1, say a2 dot dot an, so in that particular case this a1 such that should be less than a2, should be less than equals to a3, like that. So the thing is that the data structure that we use to implement is array, that an array. So that means an array that is an, that consists of n elements. It consists of n elements, and the number that we wish to sort, that is known as key. So what we have to do first, say I have to run a loop from j is equals to 2 to ln. Then I will take an example explaining that what I am written there, and say I am taking a key is equals to aj, and the thing is that say I is j minus 1, and why this value of I is greater than 0 and ai is greater than equals to greater than key, then what we have to do, we are just putting, that is within the while loop, ai plus 1, that should be ai should be less than a plus I minus 1, and I plus 1, and I should be make I minus 1, and at last what we have to do, after this a I plus 1, you are just putting the key. So what I am doing here actually, that means say initially this is the thing, say this is an array, this is say 5, 2, this is 4, this is 6, this is 1, this is 3. So when we are explaining data structure, say the indices that will be started from 1, right? So say, but the j will be started from 2, right? J will be started from the value of j is equals to 2. So in that particular case, this is the value of this is the value of j, right? Because j will be started from 2, and the key in that particular case is equals to a2, that means that is nothing but 2, right? So this is the second step, and I equals to j minus 1, that means I will be pointing there. So what you have to check, that while I is greater than 0, yeah, of course I is greater than 0, and ai is greater than key. Ai means in that particular case ai is nothing but 5, and that is greater than key is 2, right? Key is 2. If this condition is satisfied, then what we have to do, ai plus 1 should be equals to ai, right? So this is ai plus 1, right? This is the ai plus 1. So what is the thing, that means ai plus 1, we are putting the value ai. What is the value of ai? Ai is nothing but 5. So this 5 will be ai is nothing but 2, right? That will be what is this, ai plus 1 ai. So ai should be placed in ai plus 1. So this position is ai plus 1, so this become 5, right? This become 5, this become 5, and at last what we have to do, after completion of this, that means this is the within while loop, and after completion of this, what we have to do, the value of key that should be placed in a plus 1. That means after that what will happen, again the value of I will be greater, right? But that means, in that particular case I is equals to j minus 1 and I is greater than 1, and the value of I will be decremented, and value of I will be decremented. That means what should be the value of I? So you are copying this value, and again the value of I will be decremented to I minus 1. So if it is decremented, then the value of I is equals to 1, because it is 0, right? Initially this is 1, so it becomes 0. So when it becomes 0, it again goes to the while loop, and the loop will break, right? The loop will break, and what will happen, this value of a plus 1, that means the a, this I is 0 plus 1, and the key is nothing but the 2. The 2 will be placed in a1 position. That means this 2 will be placed on a1 position. So the thing is that in that particular case, after after the loop, what will happen, that will be like that: 1 2, this is 3, this is 4, this is 5, this is 6. And again, again what will happen, the j will now become 3, because that will happening for j equals to 2. So when the j is 3, right, that means j is pointing there and I is pointing there, right? So this is like our hand, আমাদের হাতের তাসে কি থাকে, হাতের তাসে যতদূর থাকে, ধরো এটা হচ্ছে হাতে আছে, এটা কিন্তু শর্টেড থাকছে, দেখো এইটুকু পজিশন, মানে আবার কি করবে, জে এর পজিশন যে পয়েন্টটা করবে, এটা হচ্ছে আমার হাতের কার্ড, এইটুকু পয়েন্টটা শর্টেড থাকবে, মানে যে পয়েন্টটাই বিলং করবে সেই পয়েন্টের আগে পর্যন্ত ডেটাগুলো কি থাকবে, ডেটাগুলো শর্টেড থাকবে, ডেটাগুলো শর্টেড থাকবে। সো ইন দ্যাট পার্টিকুলার কেস হোয়াট উইল হ্যাপেন, এখানে তাহলে আমরা কি দেখতে পাই, এখানে দেখো তুমি আবার দেখো ভালো করে দেখবে যে হোয়াট উইল হ্যাপেন। Now in the second case j is equals to 3, so what is key? Key is nothing but aj, right? So aj means a3, a3 means 4, right? So now what is value of I? I is j minus 1, so j minus 1 means I is equals to 2, right? So I equals to 2. So now what will happen, I equals to 2 and I is greater than 0, and ai, that means a2, and what is the a2 is equals to 5, and whether this 5 is greater than equals to key value is nothing but the key in that particular case, that is 4. So that if this condition is satisfied, then again the same case will be happening, that means ai plus 1, this is the I plus 1, that will be replaced by ji. Ai is nothing but 5, so that will be replaced by 5, and I will be again I minus 1, so again the value of I is become 1, and you are again computing the while loop, that means I is greater than 0, and whether you have to check ai is greater than key or not. What is ai then? Ai, right, that means a1, that is 2, whether 2 is greater than equals to key is been fixed for that particular case. So the key that we find, that is 4, but this condition is not satisfied. If this condition is not satisfied, then again I will be decremented, I will be I minus 1, that means I equals to 0, and if I equals to 0, it will out of the for loop, and what will happen, ai plus 1, we are placing the value key right there. So the thing is that in that particular case what will happen, this value will be replaced by ai plus 1, that should be ai, that means in that particular case this particular value, that means this 5, that will be placed with 4, that means 4 is the value of key, so we are just replacing I plus 1. So the thing is that in that particular case what will happen, 2 4 and 5, right? So it will be working like that, it will be working like that. So the thing is that if this is out of the for loop, so the value of I equals to 1, we just know. So that's why that will be within the for loop. I am making the wrong. That means in that particular case the value of I become 1 because it is the out of for loop. If it is the out of while loop, the I will not decrement, and after out of the for loop you just replacing the value of key into I plus 1. So I plus 1, that means this is 1 plus 1, that means this is the a2, and a2 value we are placing the value of key is nothing but 4, so that's why I am writing there. So that should be 2 4 5. That means the main case, the main thing of insertion sort is what the j is pointing in what positions. Up to this, the element are already been sorted. That means this is j is pointing here, that means you just see that are sorted. Now if the j is pointing in the next location, that means in the next case this is 2 4 5, this is 6, this is 1, that is 3. Now j is pointing like that, you will also see that up to j point the elements that are being sorted. So j will be incremented, and then you are sorting the thing, that's all. So that is the concept of insertion sort, right? That is the concept of insertion sort. And if if you calculate, I am not going to details to calculate the complexity, but that is also one of the thing that you need to know. And also the thing is that in that particular case, if you analysis the complexity that will be done later, then you will see that in case of uh, average case, in case of best case it will be take order of n, but in case of worst case or average case it will take order of n square. That will be happening. So that is the examples of insertion sort. That is example of insertion sort. And there is another thing that is called selection sort. This is another thing, this is called actually straight selection sort. This is a straight selection sort. This is a straight selection sort. So in case of straight selection sort, what we should do, that means in that particular case we will take the first element, right, and we are taking it as a minimum element, and then we are comparing with the rest of the element. Then what will happen, we will see that, say the elements are given like that, say elements are like that, that means 4 6 7 5 9, this is 3, this is 1, this is 8, this is 2, and say the index are 1 2 3 4 5 6 7 8, this is 9. So the thing is that in that particular case, first we can take the first element as a minimum element, right? So say first we can take, say the minimum element is a1 location, we are taking it in a minimum variable, and that is 4. Now what will happen, this 4 will be compared with 6. If if 6 is greater than this, then no problem, but if this particular value will be less than 4, then you are replacing the minimum, right? So the thing is that then it will be compared with this, it will be compared with this, because 4 is always minimum of if we compare with 6 with 4, then 4 minimum, 7 with 4, 4 is minimum. So when we are comparing with 3, what will happen, now 3 will be minimum. When you compare with 1, the 1 will be minimum. That means minimum element every time that will be stored in minimum variable, right? You have to compare with 8, you have to compare with 2, then you will see that what is the minimum value, the minimum value is nothing but 1, right? This is the corresponding minimum value. তার মানে আমরা একবার লুপটা চালিয়ে কি পেলাম, আমরা কি করলাম, মিনিমাম ভ্যালুটাকে পেয়ে গেলাম। তাহলে মিনিমাম ভ্যালুটা যদি আমি পেয়ে যাই এবারে, তাহলে মিনিমাম ভ্যালুটাকে আমাকে রাইট পজিশনে বসাতে হবে। তার মানে এই যে ফার্স্ট পজিশন যে ভ্যালুটা বসিয়েছিলাম তার সাথে এই পজিশনটাকে সোয়াপ করে দেবো, রাইট? ফার্স্ট থেকে এটাকে আমি সোয়াপ করে দেব। তার মানে আমার যেটা হয়ে গেল অ্যারেটা 167593482। নেক্সট কি করব আমি, প্রসেসটা ইজ সেম। নেক্সট আমি ফার্স্ট এলিমেন্টটাকে ধরবো না, ফার্স্ট এলিমেন্ট অলরেডি বিন প্লেসড ইন দ্য right positions. So in that case minimum will be take as a 6 because this is the next element, and again we are comparing 6 with 7, 6 with 5. When we are comparing 6 with 5, 5 is less than 6, it will be updated and it becomes 5. 5 with 9, no problem. 5 with 3, it will be updated, that becomes 3. 5 with 3 with 4, no problem. 3 with 8, no problem. 3 with 2, right? So it will be updated and the minimum is 2. So minimum is 2. Then what will happen, this 6 and the position of 2 are interchanged. So the thing is that if we do the same process repeatedly, then after some time what will happen, all element are will placed in a proper positions. So that is nothing but the selection sort, and that is that is the simplest sort, right? After bubble sort you can do the selection sort right there. That means you can take the first element, that is minimum element, and you can say you can check this particular minimum with the rest of the element, and you can, if the uh, if you can find the rest less than that particular minimum element, you just you can just store this particular index into minimum, and after doing the operations you are just swapping the value. That means what I'm saying, that uh, if you can write the loop, so write the loop, that means I'm saying that you are just writing for equals to I equals to 1, say I equals to 0, I less than n minus 1, I plus plus. And the thing is that what I'm saying, that minimum is an element, you can take, say I is the minimum, because when I equals to 0 the minimum will be, and then you are applying this particular for loop, say from I plus 1, j is less than n, and j plus plus, right? And now if you are checking right that means within this we are checking if this this minimum if greater than equals to this, that means যদি মিনিমামের চেয়ে কোনো আমি যদি বড় এলিমেন্ট পাই, যেমন অ্যারে মিনিমাম কি ফার্স্ট পজিশন মানে a0, তার মানে ফার্স্ট এলিমেন্টের সাথে কম্পেয়ার করছি বাকি সব কটা এলিমেন্টের, এবং যখনই ফার্স্ট এলিমেন্টের চেয়ে অন্য কোনো ছোট এলিমেন্ট পাচ্ছি, মানে যখনই এই মিনিমাম এলিমেন্টটা বড় হয়ে যাচ্ছে যে এর কোনো একটা এলিমেন্টের চেয়ে, তখন আমি কি করব, সেইটাকে মিনিমাম হিসেবে ধরে নেব, right? So this is the loop. After completion of the loop, after completion of the j loop, তার মানে এই লুপটা একবার চালার পর কি হবে, এই যে মিনিমাম এলিমেন্টটা মিনটা সবসময় কি করবে, তখন যেটা সবচেয়ে মিনিমাম সেটাকে স্টোর করে রাখবে। এবারে যদি স্টোর করে রাখে তাহলে আমি কি করতে পারি, যদি এই ঘটনাটা পুরোটা ঘটে যায়, তার মানে আমি মিনিমামটা সবসময় কি মিনিমাম এলিমেন্টের ইন্ডেক্সটাকে স্টোর করে রাখছে, তাহলে মিনিমাম এলিমেন্টের ইন্ডেক্সটাকে যদি স্টোর করে রাখে তাহলে আমরা কি করব, সোয়াপ করে দেবো। কাকে সোয়াপ করে দেবো, এই তোমার মিনিমাম এলিমেন্টের সাথে, মানে অ্যারে অফ দিস মিনিমামের সাথে এই যেটাকে আমরা ধরেছিলাম, মানে জেড এলিমেন্ট আমি ধরেছি, তার মানে জেড পজিশনে আমি মিনিমাম এলিমেন্টটা পেয়েছি এই অ্যারে অফ এই জে এর সাথে আমি কম্পেয়ার করে এটাকে করে দেবো, তাহলেই আমি কি করব, সোয়াপিংটা আমার হয়ে যাবে। দ্যাটস অল। আমি তাহলে এটার সাথে এটার সোয়াপিংটা আমরা এইভাবে করে নিতে পারব। দেখো, আই থিঙ্ক দ্যাট উড বি ক্লিয়ার। This is AI. That should be, I think, whether it makes sense or not. Right? So that is the concept of selection sort. But the important observations that you should notice, that if we count swapping, right, if we count swapping, so the thing is that in case of bubble sort, if we observe bubble sort, then the number of swapping that will take n into n by minus by 2, that means order of n square, right? Number of swapping n square times laggy in case of when we are dealing with the bubble sort. So the number of swaps that the number of, it has been shown that number of swaps made by insertion sort, on the average is exactly what is for bubble sort, what is about the bubble sort. And of course we know that swap is an expensive operations. We can easily see that in case of selection sort, the number of swap that will take less than that. That means if the size of records is very large, that the procedure swap, which is not only placed in the tree algorithm where the records are copied, that will take far more time than any other steps, such as comparison of keys and calculation of array indices. All other things are done in case of swapping. The swap is a very costly operations, right? And of course in case of bubble sort, what we will see that will take is near about n square by 2 times, that will take the number of the swap. So but when we are dealing with insertion set, that will also same as that. So the thing is that, but in case of selection sort, that will take order of n, right? That will take order of n. That means in selection sort, the in selection sort number of swap, that will take order of n, right? That is the most you know you can think of that. In case of selection sort, or in case of insertion sort, in case of bubble sort and insertion sort, while it will take order of n square, but in case of selection sort it will take order of n. That is the improvement. That means the number of swapping is less in selection sort compared to the bubble sort and insertion sort. And compared to the bubble sort and insertion sort, what is the thing that will order of n? So this is the case that you should know. So